Okay, in this video we will learn about different kind of graph plotting that can be displacement versus time, velocity versus time, or acceleration versus time, and what to understand from these graphs. So first we will learn the interrelation between these quantities: displacement, velocity, acceleration. So we know that velocity means displacement by time. Suppose you go from A point to B point, doesn't matter in which path you have gone, but displacement is always the straight line distance from A to B, that is minimum distance. So if you denote this displacement, the length from A to B, as S and the time as T, then this will be, and we generally write velocity as V. So the displacement is S and time is T, so V equal to S by T. Now that is total displacement by total time, but now if you try to find instantaneous, suppose this is point A and this is point B and you have moved like this, but I'm not interested in the average velocity, but I'm interested in what was the velocity at this point, what was velocity at this point. So I'm trying to find instantaneous velocity. So in that case I have to know that displacement, suppose at different times, suppose when the object was here, in that time displacement was this, when here the displacement was this. So suppose then I have to know is as a function of t, but I am trying to find when t equal to t naught. Suppose when t equal to t naught, the object was at this point, so we need to find velocity at particular this point. So what I have to do, we know that v is instantaneous velocity is delta s by delta t, and you have to take limit on it, limit delta t tends to 0, so that will be ds by dt. That is the, because this was the definition of our differentiation, so ds dt. So we can if we know s as a function of t, then we can easily find d dt of s, and when we will find d dt of s, then if you put t equal to t naught, then you will get velocity at this particular point. So instantaneous, for instantaneous velocity we know v is d dt of s. Again, so if v is d dt of s, then we know s would be integration v dt, because we know that integration is anti-differentiation. Again, acceleration, we know acceleration is velocity by time. So a is equal, we will write acceleration as small a. So a is equal to, if you are finding average velocity by average time, in that case then it will be v by t. But if you are trying to find instantaneous acceleration but at a particular point, then it will be as dv dt or d dt of v, and so v will be again integration a dt, as similar like this one. So this is average case and this is instantaneous case. Suppose you have given a value of v and value of t, then you will find acceleration just by dividing the value of velocity by value of time. But if you are given velocity as a function of time, then you have to find ddt of v, then you will get acceleration. Now we got the interrelation between velocity, displacement and acceleration. Now we will plot these things. So first we will start as displacement versus time. So here in this side s will be increased. Suppose we are writing it at meter scale, so suppose this is 1 meter, it is 0 point, and then there I am representing displacement in y-axis, so it will be 1 meter, it will be 2 meter, it will be 3 meter, 4 meter, 5 meter, 6 meter, and so on. And there in x-axis we will represent time. So suppose this is 1 second, this is 2 second, this is 3 second, this is 4 second, this is 5 second, 6 second, 7 second, 8 second, and so on. So suppose I am standing at point A and with time I am not moving. So time is going on, but my displacement is 0. So the graph will be the x-axis itself. And now suppose I am moving 1 meter in each second. Suppose I am after 1 second I go 1 meter, and again after 1 second I move another 1 meter again, and I am moving in a straight line. So after 3 seconds I move 3 meter, after 4 seconds I move 4 meter, and so on. So and suppose in 6 seconds in this way I moved 6 meter and reached to point B. So the plot will be at t equal to 0, at the initial time I was at point A, so my displacement was 0. After 1 second my displacement become 1. So after 1 second I reached at this point, and I am moving with uniform velocity. So and after 2 seconds I moved 2 meter distance, so I will reach at this point. After 3 seconds I will reach 3 meter. Similarly after 4 seconds I will reach 4 meter. After 5 seconds I covered distance as my displacement is 5 meter. After 6 seconds my displacement is 6 meter. So the graph will be like this. As I am moving with uniform velocity, so the graph will be like this. So this is my displacement versus time graph. So in this graph, what is, if you know that v is equal to ds dt. So from this graph, the slope of this graph will be your velocity. And if I say that find how much distance you covered, then you can easily find 6 meter you covered in 6 seconds. So that is easy. But and what was your velocity? That is ds by dt. What was your ds? Suppose you covered 6 meter in 6 seconds, so slope of this curve will be, this distance is 6 meter and this is 6 second, so ds is 6 by 6, 6 meter by 6 seconds, so that will be 1 meter per second. So your velocity is 1 meter per second here. Now suppose you are given a curve, another curve, x-axis there is t, and in y-axis you plot s. But this curve is not uniform. Suppose in every point you are your speed is changing. So suppose you move in this way. S is a complex function of t, and you have to find what was the speed at this particular point. Then you have to draw tangent at this point and find the slope of this tangent. Thus, because you know that v is equal to ds dt, and ds dt represents the slope of tangent, so you have to draw the tangent and find the slope. In that way you can get what was the velocity at that point from distance versus time curve. Similarly, next we will see velocity versus time graph. This was displacement versus time, s versus t curve. Displacement versus time curve. Now we will see velocity versus time curve. So in this y-axis we will plot v, and x-axis we will plot t. Now this point is origin 0, 0. So here t is 0 and v is also 0. So now if I draw, suppose there is in a point I am my initial position, and I reach to b at a uniform speed. Always my speed was uniform. Okay, so if my velocity is uniform, suppose I am moving in straight line a to b, and my speed is also uniform, so my velocity is uniform and constant. So in that case I will get a constant value. That means value of v is not changing with time. Okay, suppose my speed is v naught, so here the value of this will be v naught. Okay, so now you know that if your speed is v naught, so and if you cover this distance at t time, so the distance is v naught into t, because you know v is equal to s by t, so s equal to v, you know v equal to s by t, so s must be equal to v into t, and as v is constant here, so s is equal to v naught into t. So suppose you take t time, suppose the value of t is this much. So suppose here he was in a point and here he was in b point, so the distance you covered will be the area of this area under this curve. So suppose this is v naught, because you know the area of a rectangle is length into depth, length into breadth, so v naught, and this length is t. Suppose this is, suppose I say that you take time t naught, so this length must be t naught, so v naught into t naught will be your displacement. So we'll get, so if I have to find displacement from velocity versus time graph, we have to calculate the area under that curve. Now suppose we take a random curve, suppose this is v and this is t, suppose this is a random graph. Now this is point A and this is point B, so v is here a function of t. and in each time v is changing. So now if you find area under this curve, you will what you will get. So you have to find v dt, integration v dt, and we have learned in the video of integration that integration is known as integration has two aspects. One is anti-differentiation and one is continuous sum. Here integration means continuous sum. That means at any value t, if you take a thin slice and the width of this is dt and the value of this is v, so v into dt, that is the area of this slice, and if you add many slices from this point to this point, you will get the area under this curve. So that's why the integration is also called continuous sum, because you are summing the area of these different slices. Suppose you take many slices as this, suppose you take many slices like this and find in each area and then sum all these areas, then you will get the area under this continuous curve. So that's why integration is also called a continuous sum. So integration v dt will give you here the net displacement from a to b, or suppose this is point ta and this is tb, so ta to tb will give you the net displacement here. And if you have to find acceleration at any point, then you just need to draw a tangent and find the slope of that tangent, because we know that dv dt is equal to a. Okay, and similarly if you draw a graph, that is y-axis gives you acceleration and x-axis give you the value of time, and then suppose there is a random curve like this, and in this graph if you find the area under this curve, suppose integration a dt from ta to tb, what you will get? You will get the velocity. Okay, because we know dv dt equal to a, so integration a dt is giving you the v, so it will give you vb minus va. Okay, and the slope of this graph will give you dA dt, and that is what is the rate of change of acceleration with time. And if the a versus t curve, if a versus t curve is constant, that does not mean it's going through uniform velocity. No, if acceleration versus time is constant curve, that means you are moving in a constant acceleration. That means your rate of change of speed is uniform. That means speed is increasing in a constant manner. Okay, speed is not constant, speed is increasing in a constant manner, then that is your constant acceleration gives. Thank you.